Thanks. Thank you. So Rose, floor is yours.
Okay, good to go. Thanks a lot, Anne, for that introduction. It's really exciting to be here. Thanks everyone for coming. I'm speaking to you late at night from the lands of the Wurundjeri people of the Kulin Nation, and I'm going to be telling you a story about the open science movement in 10 parts. So part 1. Once upon a time, scientists earned status and jobs by publishing new or surprising results. So I'm not saying that this is true for everyone, everywhere, but let's imagine that it is true for Olive, a PhD student in an ecology and evolution department at a research-intensive university. Olive loves doing research, and she would love to one day become a tenured professor and run her own lab. It would be perfect if she could do that close to where her family and friends are. She knows this is unlikely to happen. She has been to career advice workshops, read the blogs, talked to mentors, she's heard the stats. She knows way more people want these jobs than there are jobs available, and the grants and fellowships she knows about all have low success rates, but still she wants to try. To get through these tight bottlenecks, she will be evaluated by selection committees that will be short on time or short on expertise or both. And so they will rely on proxies of Olive's research productivity and quality, especially the number of papers she's published, the prestige of the places that she's published in, and the number of citations she has received. So Olive wants to publish as often as she can in the highest impact factor journals that she can. She does confirmatory hypothesis testing research, and she hopes to find positive, surprising, groundbreaking results. Looking at what gets published, it seems that scientists are finding these positive results everywhere they look. On this graph, you're seeing the percentage of published papers that found support for the hypothesis they were testing across different fields. They're all well above 50%. And if scientists are finding support for their hypothesis most of the time, this could mean that they're being very cautious in the claims that they're testing. They're not taking big swings. They're testing things that have a high prior probability of being true. But at the same time, scientists write about their results like they are groundbreaking, unique, novel, and important. The use of these hype words in abstracts and grant applications has gone up and up over time. And this hype is on the rise because it's what the high impact journals reward. Work that's rigorous but more speculative or exploratory gets recommended for more specialist and lower impact journals. Olive learns this, and she has finite resources, and she wants to allocate them in a way that maximizes her chances of getting through those bottlenecks. So what happens next? Part 2, and every day, scientists used questionable research practices to maximize their publication output. By questionable research practices, I'm referring to a set of behaviors that researchers do that helps them get published, and at the same time, it makes it more likely that their results don't replicate, they're false positives. If you ask researchers in ecology and evolution, most people are aware of themselves doing some of these practices at least some of the time, and they probably happen more often than we were aware because questionable research practices are easy to do without noticing you're doing them, and they're easy to justify to yourself. So here we're not talking about outright research misconduct or fabricating data. I'm talking about practices that Olive might be taught to do as a PhD student, like harking, which means hypothesizing after results are known, and selectively reporting the most interesting results. So perhaps like me in grad school, Olive reads The Scientist's Guide to Writing, which emphasizes the importance of finding and planning your story. She reads, quote, "You must decide which information, data, analyses, and interpretation belong in the paper and which are better reserved for another manuscript or abandoned to a dusty row of old notebooks." She has a lot of decisions to make. When does Olive stop collecting data? What does she do about outliers? What type of model does she use? How much should she care about the violation of model assumptions? What covariates does she include? Does it make sense to include an interaction term? Who knows? Olive faces a garden of forking paths. It's not obvious which direction to go down, so Olive might try a bunch of different ways and see where they lead her, then choose the path that has the most compelling result at the end. So this is known as p-hacking, and is often taught to many students by famous professors like Brian Wanzig. He boasted about this in a 2016 blog post when he was writing about a visiting student to his lab. Quote, "When she arrived, I gave her a data set of a self-funded failed study which had null results. I said, this cost us a lot of time and our own money to collect. There's got to be something here we can salvage because it's a cool, rich and unique data set. I had 3 ideas for potential plan B, C, and D directions since plan A had failed. I told her what the analyses should be and what the tables should look like. I then asked her if she wanted to do them. Every day she came back with puzzling new results, and every day we would scratch our heads, ask why, and come up with another way to reanalyze the data with yet another set of plausible hypotheses. Eventually, we started discovering solutions that held up regardless of how we pressure tested them. I outlined the first paper and she wrote it up, and every day for a month I told her how to rewrite it, and she did. This happened with a second paper and then a third paper, which was one that was based on her own discovery while digging through the data. This is an amazing blog post. It goes on to contrast the success of that particular student publishing all those papers, well done her, with a much less tenacious postdoc who published at a quarter of the rate and left academia. In the same year, 2016, Paul Smaldino and Richard McElreath published The Natural Selection of Bad Science, which is based on the pressure to publish or perish. In their cultural evolution model, successful labs publish lots of papers using questionable research practices, and those labs train more people who go on to run labs of their own and propagate those same bad habits. By selecting the most productive researchers, the quality of published science is driven down. Part 3. Until one day, the status quo became intolerable in high-profile fields. Science is a complicated cultural process. How can we tell when it is working well? If you build a bridge and the bridge falls down, everyone notices. It's super obvious that your bridge was bad, that something went wrong, and then people try to fix it. But if your research is steps removed from any eventual application, and for fundamental research, it's not so obvious when you've built a dodgy bridge or a house of cards. People have to really pay attention and they have to care to notice. People are more likely to pay attention when there's fame and fortunes and lives on the line, when the ethics are clearer. And this happens with the issue of publication bias in clinical research. Pharmaceutical companies would like their drugs to be approved and prescribed and make millions of dollars. So left to their own devices, too often they will choose to only publish the results that make their drugs look good. And because of that ethical failure, governments and funders had to mandate that all clinical trials be registered in a repository before they begin, and all the results need to be published. But that didn't solve the selective reporting problems that are happening earlier in the bench-to-bedside research pipeline. It doesn't address publication bias in preclinical research. And one sobering example of this failure comes from research into treatments for ALS. ALS is the motor neuron disease where over the course of 2 to 4 years, you lose the ability to speak, eat, move, breathe, and then you die. People donate a lot of money to medical research to try and find treatments and cures for this devastating disease, as we saw with the Ice Bucket Challenge internet phenomenon in 2014. At the time of that fundraiser, there had been several drugs that had gone all the way to clinical trials in humans because they had shown promise in mice, but they all failed. In humans, none of those drugs helped at all. So frustrated people went back to the preclinical trials in mice, and they found that those initially promising results had vanished. They had all been false positives. Those drugs should never have been given to humans before the results were replicated in mice. The bridge fell down. I think because these disasters unfold slowly, often in complex, boring ways, it's taken a long time for people to be as appalled by this as they should be. It's been 30 years since Douglas Altman published The Scandal of Poor Medical Research. We need less research, better research, and research done for the right reasons. But slowly, the open science movement did spread from medical research to other disciplines. Part 4. And because of that, concerns about research waste spread across the life sciences. So the open science movement really grew in the 2010s through the concept of a replication crisis. And one of the defining papers of this era was published in Science in 2015. It was called Estimating the Reproducibility of Psychological Science. This was a big project led by the Center for Open Science, where they enlisted lots of labs to try and replicate the results from studies published in psychology journals. From 100 different replication attempts, the headline result was that most replications found much smaller effects than the original studies, and most p-values were no longer statistically significant. And there have since been more replication projects like this, including in economics and cancer biology, and they have all been drawing attention to how rarely we normally conduct replication studies, how hard it is to work out what authors did to even begin to attempt to do a replication study, and how studies can become very famous and influential while at the same time being unreliable. So these collaborative replication projects receive so much media coverage that those conversations have permeated into other fields before they had quantified their own replication crisis, including ecology and evolution. But other than these replication failures, people's attention has really been captured by high-profile cases of fraud. My home field of animal behavior has had a few famous fraud scandals in recent years. I'm thinking of the effects of microplastics and ocean acidification on fish behavior and the rise and fall of spider researcher Jonathan Pruitt. This case in particular led some of the journals that were affected by those retractions to reassess their policies and tighten their standards around data and code sharing. And so I think these fraud cases are to open science what charismatic megafauna are to conservation biology. The analogy here is that in the same way that all the effort put into conserving pandas has general positive impacts on biodiversity where pandas live, fraud cases cause people to sit up and take notice and introduce more layers of accountability that will make fraud harder to commit or at least easier to detect. And at the same time, that accountability also works to reduce the more common questionable research practices done often by honest researchers like p-hacking and harking and selective reporting. Part 5, and because of that, research is becoming more open and transparent. Okay, so what changes have we seen in recent decades because of the open science movement? Well, transparency has increased a lot. A big reason for that is that the infrastructure is there to make it possible. Now journals are online, you can attach supplemental files to papers, people are sharing more results and protocols and details of their methods. And transparency has been encouraged by the research community with many opinion papers on open science, and we have reporting guidelines and checklists to try and increase the reporting quality of our research outputs. A big chunk of my PhD was spent developing one of those checklists for systematic reviews in ecology and evolution. If you have done a meta-analysis, then you will know the deep frustration of not being able to work out how studies were done or what their results were. But it is definitely getting easier for studies published more recently to find that information. Transparency was really helped in 2010 when a group of journals all jumped together and required data to be publicly archived for papers published from 2011 onwards. Slowly, these sharing requirements are also being introduced for analysis scripts and the code associated with papers too. And just recently, eco-evo journals are starting to enforce their data and code sharing policies by having data editors check that authors are actually doing what they say they're doing. In other fields, there are journals that are going as far as having someone check for full computational reproducibility. So that means someone runs the code to check whether it will reproduce the results as reported in the paper. We're a long way from that. That's a lot of work, but we're still doing better when it comes to data and code sharing than many areas of psychology and medicine. But we have some catching up to do in terms of making it more transparent when researchers are doing those questionable research practices like harking, p-hacking, and selective reporting or cherry picking. And the way to make that more transparent is to use registration or pre-registration, where you write down what you're going to do before you do it, and you put that record in a time-stamped, publicly available repository. So as we've seen, that's mandated for clinical trials, and it's uncommon in psychology, but it has increased a lot in recent years. There is a limitation to pre-registration in that it doesn't do anything to address the issue of publication bias at the level of journals. But for that, you need registered reports. So registered reports is different to pre-registration. I know it is confusing because they sound so similar, but they're different things. Registered reports are a change to the traditional publication model where instead of writing your paper after you've done the study and got your results, you first write the introduction and methods and you send that to a journal for peer review. Reviewers give you feedback, you might improve your methods, and the journal can offer you a provisional acceptance where they agree to publish your paper regardless of what results you find. At the moment, there are some journals in ecology and evolution that offer registered reports, but I'm hoping that they will become more popular. What else has changed? Well, in recent years, we've seen more pressure on journals to be more transparent about how they operate behind the scenes. Some journals now publish the peer review history of their papers and include the names of the handling editors. And for many people, open science is most closely associated with open access, with the push for scientific outputs to be open for everyone to read. There are major funders requiring that researchers publish their outputs in open access journals, or at least make their research freely available as a preprint or a postprint. Preprints were used by physicists for decades, but they've now gained a lot of traction in the natural and social sciences, especially following the urgency of the COVID-19 pandemic, when the traditional publication system was shown to be just too slow and not fit for purpose. There are other changes I haven't mentioned, but my takeaway message for this part of the story is that researchers are sharing way more information than they used to. This is true for both individual research outputs, and it's also true for the volume of research outputs. Researchers like our friend Olive, trying to get through those bottlenecks to get funded and hired, they are expected to publish way more than they used to. But at the same time as being more productive, they're also expected to do everything more transparently and make more information available for every paper. Something's got to give. Part 6, and because of that, more is being asked of researchers than ever before. Olive is curious and passionate about her research, but Olive is also tired. She's spending all of her time trying to be productive enough to keep up with her peers while also being worried about staying employed and winning funding. And on top of all that, she's now being asked to create these massive supplemental files and learn to write reproducible code and write descriptions of all her data variables and where's she going to get the money from for those open access fees. And how's she going to pre-register her analysis plans when she doesn't know that much about stats? It's just a lot, okay? It's a lot. Last year, the Nobel Prize in Economics went to a woman named Claudia Golden, who writes about greedy occupations or greedy jobs. A greedy job is one that expects long working hours, or it expects a level of productivity that few people can achieve without long working hours. And so greedy jobs will filter out people who can't or don't want to devote their free time to work. Academia is a greedy job. I bring this up because it's an issue of fairness and because most of the changes that have come about from the open science movement are individual solutions to what are systemic problems. I started this story with, once upon a time, scientists earned status and jobs by publishing new or surprising results. That has not changed. If anything, the competition for jobs and funds has been exacerbated by budget cuts during the COVID-19 pandemic. Here in Australia, if you compare early career researchers to people in other professions at a similar career stage, researchers are expressing more distress and dissatisfaction with their work life than is normal. Selecting on productivity will further marginalize people who are disadvantaged to begin with. Some people think this is okay, though, that because science is so important to society and solving global problems, we need to promote productivity. The science has to come first. But that argument falls apart if productivity isn't related to quality, or even worse, if it's inversely related to quality, as in the model of the natural selection of bad science. Yes, much has changed to make research more transparent, but what is all that transparency for? It's meant to allow people to evaluate what was done. Olive can be transparent about what she did without what she did being any good. Transparency just makes it possible for others to evaluate whether what she did was good if they have enough motivation and time and expertise to do so. Those are all big ifs. So Olive does her best. She starts sharing data, but it has errors in it that no one notices. She pre-registers her studies, but no one reads them. She shares her code, but no one runs it to check whether it reproduces the results in her papers, let alone actually redoing her studies to check whether they replicate. So no one ever finds out if they're false positives. Part 7, and because of that, transparency is insufficient for ethical and fair research. I think it is telling that there are almost no replication studies published in ecology and evolution journals. Many studies would be feasible to try and replicate. At least in my home field of behavioral ecology, there are a lot of short-term studies done on common systems that multiple groups have access to, where you wouldn't need special funding or a lot of effort to replicate them. And there are journals that are happy to publish replications. They just don't get any submitted. I think the dearth of replications is an implicit acknowledgement of weak links between the outcomes of individual studies and the broader theories or the problems that we're interested in. It's like this XKCD cartoon where a researcher says, we want to study this variable, but it's hard to observe, so we're studying this proxy variable. When asked, is it correlated with the other variable, the researcher doesn't know. And the caption to this cartoon reads, our work has produced great answers. Now someone just needs to figure out which questions they go with. So more information is made available than ever before, yes, but we weren't making the most of the information we already had available. We have the infrastructure for communities to do post-publication critique with websites like PubPeer, but they mostly go unused. And there are undeniably big social cohesion reasons why we don't dig into each other's papers and cause a fuss when they're unreliable. I think we'll be hearing more about that in the next talk. But quality control is also rare because most people are busy and stressed, and they're just doing their best under difficult circumstances. The university that I work at is a signatory of DORA, the San Francisco Declaration on Research Assessment. And this is meant to do something to change how researchers are evaluated. It's meant to be reducing the publish or perish pressures. But in practice, I hear of people who sit on selection committees and they are given 100 job applications and less than a week to produce their shortlist of fewer than 10 candidates. It is simply impossible for them to evaluate the quality of people's research in that time. All they can do is use indirect measures of productivity and impact and transparency, which can all be gamified. So open science becomes open washing. Goodhart's law: when a measure becomes a target, it ceases to be a good measure. Part 8, and because of that, the way scientists earn status and job security is slow to change. The more things change, the more they stay the same. If I sound fed up, it's because I am, and I'm not alone. While our friend Olive is doggedly pursuing her dream of professorship, many other tired early career researchers are opting out of the systems they're unhappy with. This can mean they change institutions or change research fields, or they change careers entirely. Over 50 years ago, Albert Hirschman wrote that the only time that exiting works to improve what was bad about what you left behind is when the people or the institutions that you walked away from care that they lost you. They have to miss you when you're gone. I keep seeing the people who agitated the most for change in the open science movement leaving academia, or at least leaving the fields of research that they used to be interested in. What happens once the most agitated early and mid-career researchers have left? Maybe the feeling of crisis will subside and things will carry on much as they were, with careers built on individual productivity. I think that would be bad for science and bad for scientists for some of the reasons that are outlined in this talk by Richard McElreath called "Science is like a chicken coop." He draws an analogy between groups of scientists and groups of chickens. As scientists, we want to maximize both basic and applied knowledge, while chook farmers want to maximize egg production. In academia, we are selecting for individuals who produce the most papers, who get the most citations. But they tried that with the chooks and it went horribly. It meant they bred the most aggressive, antisocial hens, the ones that will peck or even kill each other. It's bad for the eggs and it's bad for hens. So instead, the chook farmers turned to group selection. They selected for the chicken coops that produce the highest egg counts, and that drastically improved their overall production of eggs, as well as decreasing the amount of bullies and cannibals. Doesn't that sound nicer than pecking each other to death? So here is a paper that extends on that argument that we should be promoting teams in science a lot more than we promote individual superstars. Incidentally, the first author of this paper has left academia. Okay, if at this point in my story you are feeling a bit down about things, I get it, but don't worry. All hope is not lost. I will now attempt the rousing pivot towards an optimistic resolution. Part 9, until eventually, researchers banded together to change the institutions they rely upon. All of these concerns about the quality of scientific research are not new. People have been sounding alarms for decades. But I have been told by wiser people than me that something feels different this time with the current open science movement. Perhaps helped by the internet, researchers and advocates are coordinating more, both within disciplines and across them. And there's been more buy-in from institutions. Yes, most of those changes have been at the level of transparency. We can accuse them of open washing, but where some things have changed, there's hope that more can be changed too. As single individuals, institutions are unlikely to miss us when we're gone. Use your voice and you might feel like you're shouting into a void, but you can find power in collective action. And if not power, at least you can find company and camaraderie. So you can find this company by becoming a member of SORTI, the Society for Open, Reliable and Transparent Ecology and Evolutionary Biology. In December of this year, SORTI will turn 4 years old. I've been there since the beginning, and it's been growing stronger every year. At the moment, we've got a great group of 70 volunteers working across 10 committees, and our members are spread across the world. They are mostly students and early career researchers. Membership fees are optional, and we run a bunch of free events for members, including an annual virtual conference in October. It covers every time zone. It's accessible for everyone. But if you're going to the in-person evolution conference in Montreal next month, there is going to be a sortie meetup there. So please keep an eye out for that. Everyone is welcome to attend. And Sortie has lots of concrete outputs I could point to, like the preprint server, EcoEvo archive, monthly workshops and webinars. There's a virtual code club. But just in general, I think one of the most important contributions of this community is to be a home for the olives of the world to feel supported as they try to navigate the peculiarities of their careers while also conducting good research and not allowing greedy work to consume their one precious life. Part 10. And every day since then, that's up to you. I've spoken a lot about the publish or perish incentives in this talk, but I also want to give a nod to a blog post by Tal Yarkoni titled, "No, it's not the incentives, it's you." I think we should try as much as we can to band together and try to change institutional incentives, but change is hard and slow. And the only thing you can really control is how you choose to behave, what you do as a researcher, a supervisor, a student, a peer reviewer, an editor, a lab mate. Olive doesn't have to take her supervisor's advice at face value. She has some autonomy. Assuming she doesn't have one of those horrible supervisor experiences, then she might even be able to change her supervisor's mind a little bit gradually over time. The scope of open science is vast, and there are a lot of small opportunities for improvement. When you wade into all of the guidelines about best practices and how we should be doing research, remember that they are aspirational ideals. You cannot be doing everything right everywhere all at once. Do not be deterred by the overwhelming feeling of inadequacy. Try again, fail better. And do not wait for there to come a day when you feel senior enough to push back against practices you don't agree with. That day might never come. I've heard from a lot of people in what seem like positions of seniority and authority who still claim they do not feel senior or powerful enough to change anything. So if not now, when? I don't know whether the current open science movement and these increases in transparency will be a paradigm shift towards fairer and more ethical research, but there's only one way to find out. And with that, thank you for listening, and I'm looking forward to the discussion we have after the next talk.
Oh, wow. Thank you so much, Rose, for a hair-raising